Think of a postcard perfect coastline, the gentle rhythm of the waves, and then boom, a stark intrusion. This spreading slick of dark oil, shimmering almost with a toxic sheen. That really unsettling image, that's our entry point today into this deep dive. We're looking at the profound, really far-reaching consequences of oil spills on marine life, on the whole balance of ocean ecosystems.
Yeah, and these events, sadly, they're not just, confined to one little corner of the globe. We see them from the vulnerable Arctic wilderness right down to tropical reefs, those kaleidoscopes of life, and of course the busy shipping lanes that crisscross our oceans. The threat is widespread. Today, we want to focus on several kind of key incidents that really highlight the different impacts you see across various marine environments.
Right. We're going to dig into the details, the science behind some pivotal spills. There's the Exxon Valdez in Alaska way back in 1989.
For a big one.
Then Deepwater Horizon in the Gulf of Mexico, 2010. More recently, the Wakashio grounding off Mauritius in 2020. And that troubling incident with the MSC Ilase 3 near Kerala just last year, 2025.
And our goal here isn't just to list these events, right? We want to really get under the skin of it, understand the environmental fallout, the actual toll on species, the massive undertaking of cleanup, and also the ingenious solutions that are starting to emerge in response. Think of this as your shortcut, maybe, to grasping a really complex and crucial global issue.
Okay, let's start with one that I think for a lot of people was a real wake-up call. The Exxon Valdez, March 24th, 1989, Prince William Sound, Alaska, an environment just known for its raw, pristine beauty.
And it was a truly devastating blow. You're talking about approximately 10.8 million gallons of crude oil surging into those really cold waters. The immediate hit on wildlife was, well, almost unimaginable.
Yeah, unimaginable is the word. We're talking close to 3,000 sea otters died almost immediately, hundreds of seals, eagles, and a number that's just staggering. 250,000 seabirds.
250,000.
It's hard to even wrap your head around that kind of loss.
Oh. And the oil didn't just stay in one place. It spread. It contaminated roughly 1,300 miles of coastline.
1,300 miles.
Yeah, to give you a sense of scale, that's like driving from New York City all the way down to Miami. Imagine that huge stretch of vital habitat, all the food sources, just smothered, suffocated by oil. But that immediate devastation, that was really just the start of a much, much longer struggle for that ecosystem.
And the cleanup effort, that was just huge, wasn't it? Something like 10,000 people?
Oh, absolutely massive. Around 10,000 people, yeah. 1,000 boats, about 100 aircraft mobilized.
Wow. Given that huge effort, it's kind of sobering to think about how long the impact lasted.
It was a colossal undertaking, definitely. But the tough truth is, crude oil is remarkably persistent. It sticks around. Even 12 years later, scientists from NOAA, they were still finding oil residues on half the beaches they surveyed, half of them.
12 years later, that just hammers home how vulnerable these places are, even places that seem so wild and resilient. And it wasn't just the oil sitting there, was it? The consequences for the animals they dragged on too.
Precisely. Even after more than a decade had passed, populations of certain birds like cormorants and loons and also seals, they hadn't fully recovered in Prince William Sound. It really drove home this fundamental point. You just can't easily mix a thriving marine ecosystem and large amounts of oil contamination. They're incompatible.
But that disaster, that tragedy, it did force some changes, didn't it, in how we handle oil transport and safety?
It did, thankfully. The U.S. Oil Pollution Act came out of it, new regulations for oil tankers. These were direct results of the Exxon Valdez. It served as a really harsh lesson, but it did compel some much-needed changes. The key takeaway wasn't just the immediate shock, but that long, decades-long persistence of the oil and how surprisingly slow the recovery was for some species.
Okay, let's shift gears then to 2010. Deepwater Horizon, the Gulf of Mexico. This was a different beast altogether compared to a tanker running aground, right?
Oh, absolutely. Totally different scenario. This was a catastrophic failure of an offshore oil rig. And it wasn't a single spill event. It went on for 87 days.
87 days.
Yeah, spewing an estimated 3.19 million barrels of oil. That's roughly 134 million gallons into the Gulf.
Just comparing those two, Valdez and Deepwater Horizon, what were the big differences in the challenges for containment for the long-term recovery?
Well, the sheer volume in the Gulf was immense, obviously. And the fact it was coming from the seabed under pressure made it incredibly difficult to stop. The area affected by the slick itself was just vast.
How vast are we talking?
Roughly 43,000 square miles. That's about the size of Virginia.
Wow.
And it oiled about 1,300 miles of beaches, stretching all the way from Louisiana across to Florida. NOAA's assessment was blunt. They called it an injury to the entire ecosystem of the Northern Gulf.
An injury to the entire ecosystem. That phrase really sticks with you. And the oil didn't just float on top, did it? It got into the deeper water, too.
Exactly. You had the obvious coating on marshes, mangroves, beaches. But the oil also got into the deep ocean, affecting sensitive coral habitats way down below. And those effects just rippled right through the whole food web.
We saw some really distressing immediate impacts, didn't we? Especially with marine mammals like dolphins.
Tragically, yes. Over 1,100 dolphins washed up dead in the Gulf between 2010 and 2014. That's the largest marine mammal die-off ever recorded in that region. And even the dolphins that survived. Many suffered from lung disease, immune system problems, all linked back to oil exposure.
And I remember reading about one specific population in Barataria Bay that was hit particularly hard.
Yes, that's right. Experts estimated they lost about 50% of that specific dolphin population in just a decade. And without help, the projections were grim. Maybe 39 years, almost 4 decades, for them to recover. It really highlights how vulnerable these slower reproducing animals are.
And it wasn't just dolphins. Sea turtles were badly affected, too.
Hundreds of sea turtles were found coated in oil. And you have to remember, many sea turtle species are already threatened or endangered. So the long-term hit to their populations is likely substantial. We're probably talking decades for them to recover properly.
It's easy to focus on the big animals, the dolphins, the turtles, but the oil gets everywhere, right? Even down to the tiniest stuff.
Absolutely. Even plankton, the very base of the food chain, and fish eggs were contaminated. NOAA points this out clearly. Sure, some fast-reproducing things like small forage fish, they might bounce back relatively quickly if the habitat cleans up. But it's the longer-lived species, the marine mammals we mentioned, the deep-sea corals they face, a much, much longer road to recovery.
And seabirds, too, of course. That image of an oiled bird struggling, it's powerful. Like that scooter you mentioned earlier.
It really is. That oil just destroys the structure of their feathers. They lose their waterproofing, their insulation. They can die from hypothermia or even drown. Generally speaking, floating oil is the biggest immediate threat to those surface dwellers, sea otters, like in Alaska, and many types of seabirds.
So it's not just about the animals that die right away. It's these longer-term, kind of subtle health problems, problems with breeding.
Precisely. These sublethal effects are critical. Impacts that don't kill immediately, but harm an animal's ability to reproduce, fight off disease, find food. Even years after a spill, you can see things like impaired growth in corals or shifts in the tiny microbial communities that are so important for ocean health. These hidden impacts can have huge cascading consequences down the line.
Okay, let's move to a more recent event and a different part of the world, the Lacasio grounding. Off Mauritius, July 2020, a really sensitive place, biologically speaking.
Oh, incredibly sensitive.
Yeah.
Mauritius is a biodiversity hotspot. Over 1,700 marine species live there. You've got vibrant coral reefs, vital seagrass beds, important mangrove forests, sea turtles. It's an exceptionally delicate ecosystem.
And the amount of oil spilled, okay, it was less in Valdez or Deepwater Horizon, but in that kind of fragile environment, it was still a huge worry, wasn't it?
A major worry. Around 1,200 tons of low-sulfur fuel oil leaked out, and it leaked into this very clear, shallow lagoon system. Experts warned immediately. Even a relatively smaller spill in this kind of habitat, it's going to impact almost everything.
And the oil spread pretty fast, on the surface and maybe underneath, too.
Yes, it formed slicks on the surface, but also created these underwater plumes that unfortunately reached those critical coral reefs and the mangrove shorelines, which are super sensitive. At the time, specialists like Ricardo Steiner were voicing serious concerns. They predicted the toxic hydrocarbons in the fuel would bleach the corals and eventually kill them.
And unfortunately, those warnings seem to have played out based on satellite images and what people saw on the ground later.
Sadly, yes. They observed coral bleaching near the wreck, and the mangroves definitely suffered significant oiling. The local community response was amazing, though. Volunteers mobilized really quickly, building makeshift booms out of sugarcane leaves and fabric. Helicopters worked to pump the remaining fuel off the ship, and scientists from the UK and Mauritius quickly teamed up to track where the oil was going and monitor the water quality.
I remember hearing some initial good news, though, about a protected marine park nearby, Blue Bay, that it was mostly spared.
That was a huge relief, yes. Likely down to a combination of luck with the weather, the currents at the time, and those rapid containment efforts you mentioned. But the long-term picture, well, it's still a concern. Research done 3 years after the spill found oil compounds still lingering in the sediments, in the mangroves, in the lagoon.
Still there after 3 years, and it's not just the oil itself, right? It's how it changes the balance of things.
Exactly. That's a key point. In the mangrove areas, the species that were more tolerant to oil actually recovered faster and sort of took over more space, while the more sensitive species lagged behind. So you get this subtle but lasting shift in who's living there. It shows even smaller spills can have these long-term consequences in vulnerable spots. They still need ongoing monitoring there: water, seafood safety, wildlife health. It's not over.
Okay, bringing us almost up to date, the MSC ELSA3 incident off Carolina's coast, May 2025, last year. Maybe not the massive volumes of oil like the others, but it still caused quite a bit of alarm locally.
Absolutely. This was a Liberian-flagged container ship, and it was carrying a fair bit of fuel, heavy fuel oil, gas oil, plus hundreds of containers. And significantly, about 13 of those had hazardous cargo, like calcium carbide, which, reacts badly with water.
Right. Thankfully, the crew were all rescued.
Yes, all 24 got off safely, which was the first priority.
But the potential for environmental damage was definitely there. We saw reports of oil slicks, containers washing ashore.
Yeah, about 100 containers reportedly washed up. The big worry was any leaked oil or chemicals could, smother sensitive marine life, disrupt fishing. And the timing was bad, too. It happened right as the monsoon breeding season was starting for many species.
And the monsoon winds and currents would spread any spill faster, right?
Exactly. That was a major concern. But the authorities did respond quickly. Coast Guard deployed ships, aircraft spraying dispersant powder, booms were put out in key spots. Fishermen were told to stay ashore, just in case.
So it sounds like, based on what we knew then, a really major visible spill was avoided.
It seems that way, yes, which is certainly good news. And crucially, the responders managed to salvage the ship's fuel tanks before they could rupture catastrophically. That likely prevented a much bigger disaster.
Okay.
Local scientists are still involved, though. CMFRI, the Marine Fisheries Institute they're doing surveys, mapping any trace elements of oil. But yeah, this incident really drives home the point that even routine shipping, everyday cargo runs, they carry these hidden risks. Coastal communities really need to stay vigilant.
Looking across all these incidents, these different spills, some clear patterns emerge, don't they? Really concerning consequences for marine ecosystems just keep popping up. It's like a cascade.
It really is a cascade.
Oh.
First off, the slick itself, just sitting on the surface, it blocks sunlight, which phytoplankton need. They're the base of the whole food web. It also cuts off oxygen exchange. And of course, any oil they absorb is poisonous.
And then there's the direct poisoning of bigger animals.
Right. The chemical components in the oil, they poison fish, invertebrates, either if they swallow it or just absorb it through their skin or gills. And for smaller creatures, the thick oil can literally just smother them. They can't breathe, can't move.
And like we've discussed, the surface dwellers often get hit hardest and fastest.
Definitely. Seabirds, marine mammals, often the first casualties. The oil ruins their feathers, waterproofing their furs insulation, leads to hypothermia, drowning, like we saw so tragically with the otters and birds after Exxon Valdez.
But the damage goes way beyond those immediate visible deaths, doesn't it? There are these really significant, often hidden long-term effects.
Absolutely crucial point. Toxic stuff from the oil lingers in the sediment for years, decades sometimes. It builds up in the food chain biomagnification. Animals exposed early in life, as eggs or larvae, can end up with deformities, infertility. We saw long-term population drops in things like sand lance and pink salmon in Prince William Sound. And when oil sinks, it can kill coral polyps on reefs, smother life on the seabed. It disrupts breeding cycles, too, like when they had to move turtle nests during the Deepwater Horizon cleanup because the beaches were oiled.
And the recovery time, it just varies so wildly depending on the species, doesn't it?
Hugely variable. That's critical. Things that reproduce quickly, plankton, some small fish, maybe they recover in a few years if the habitat comes back. But the slow breeders, big fish, sea turtles, whales, dolphins, recovery can take decades, maybe even a century for some populations. Those Gulf dolphin populations we mentioned, projections of decades. Some Alaska seabirds and salmon stocks still not fully back after 30-plus years from Exxon Valdez. And even when the oil looks gone, those subtle food web impacts can persist, which is why long-term monitoring water, sediment, wildlife is just so essential.
When a spill happens, the human response is always massive, right? But actually cleaning it up sounds incredibly difficult, full of challenges.
It is incredibly challenging. And sometimes the cleanup itself causes problems. Remember the hot water spraying after Exxon Valdez? Meant well, but it flushed oil into sensitive streams. Bad outcome. And the scale. Thousands of people, boats, planes, all battling weather, logistics, and just really sticky, stubborn oil.
Yeah.
It feels like there's always this trade-off in cleanup, doesn't it? Between doing something fast and potentially causing other harm. There's no perfect solution.
And the tools they use, booms, skimmers, chemicals, they all have downsides.
They do. Chemical dispersants, for instance. They break up slicks, which can help natural breakdown maybe. But they can also push oil down into the water column, harming plankton. And the dispersants themselves can be toxic. Booms and skimmers, great in calm water for surface oil. But rough seas or oil that's sunk, much less effective. And inevitably, a lot of oil hits the shorelines. That means painstaking manual scrubbing, cleaning rocks by hand sometimes, which can disturb the habitat further if you're not super careful.
But these terrible events, they do often act as a catalyst, right? For policy changes, for community action.
Definitely a silver lining, if you can call it that. Exxon Valdez led directly to the U.S., mandating double-hulled tankers, the Oil Pollution Act improving funding and liability. Deepwater Horizon brought new offshore drilling rules, billions in fines earmarked for Gulf restoration.
And you see communities stepping up, too.
Absolutely. Those handmade booms in Mauritius, that was incredible grassroots action. The warnings and securing boats in Kerala. Plus, international experts often fly in to help. That collaboration is key.
I guess each disaster also exposes gaps, doesn't it? Things we need to get better at, like predicting spill movement, coordinating drills.
Precisely. And the challenges don't go away. Oil spreads fast with wind and currents, often faster than booms can contain it. Dealing with sunken oil that can resurface later is tough. And then there's the long-term worry about toxic compounds getting into groundwater or the food chain. Plus, always having to make hard choices about where to focus, limited cleanup resources, protecting a sensitive mangrove forest versus an open beach, for example.
It's not all doom and gloom, though. We are seeing some really interesting innovations, aren't we, in how we try to mitigate spill, how we clean them up.
That's a really important point, yeah.
Yeah.
We are getting smarter. Early detection is improving a lot. Satellites using synthetic aperture radar SAR can spot slicks even when it's dark or cloudy. Plus, we've got networks of ocean buoys, autonomous drones buzzing around, giving us near real-time tracking of where spills are and where they're heading. The trend is definitely shifting away from just brute force cleanup towards more targeted, maybe more sustainable approaches, using tech, using nature itself.
And the actual materials used for cleanup are getting better, too, more eco-friendly.
Absolutely. Traditional absorbent pads, often made of polypropylene, they work, but they're hard to dispose of. Now we're seeing new sorbent materials, things made from graphene foam, which sounds very high-tech, but also from recycled human hair, believe it or not, and even fast-growing plants like water hyacinth.
Human hair? Really?
Yeah. Apparently, mats made from hair are incredibly absorbent, can soak up something like 8 liters of oil per kilo of hair. And the cool part is, some research shows you can then clean these mats using oyster mushrooms and worms, breaking down the oil and turning the waste into potentially fuel or compost. Really clever circular economy thinking.
That's amazing. And robots are playing a bigger role, too, especially in dangerous situations.
Definitely. Remote-controlled boats, underwater drones. They can go into areas too hazardous for people. They can skim oil, deploy dispersants more precisely. There's even experimental stuff with swarms of small robots designed to patrol for spills and help clean up. Still early days for some of that, but the potential is there.
And what about biology, using nature's own cleanup crew?
Yes, biotechnology is a huge area of research. After Deepwater Horizon, scientists used gene sequencing and found that certain types of marine microbes actually bloomed in the oil plumes. They were essentially eating the oil.
Nature fighting back.
Kind of, yeah. So now there's a lot of work trying to enhance this bioremediation, finding or even engineering microbes that can munch oil more effectively, especially in tricky conditions like low oxygen zones deep underwater. Plus, developing green dispersants that are less toxic than the traditional ones. Yeah. So overall, yeah, a definite move towards smarter materials, smarter machines, and harnessing biology.
So it feels like, okay, oil spills might still happen, unfortunately, but we're learning from every disaster. We're getting better prepared, better equipped to respond, hopefully lessening that long-term damage.
That's exactly the crucial takeaway. We might never eliminate the risk entirely, but the hard lessons from these past tragedies, they have spurred innovation, driven vital policy changes, and definitely raised public awareness about how fragile marine environments are. And NOAA makes a really good point. Every dollar spent on being prepared can save maybe tenfold in cleanup costs and environmental damage later. It's a smart investment.
That image we started with, the oiled duck, it's such a stark symbol of the threat, isn't it? But it also maybe symbolizes the fight back by people. By science.
I think so, yeah. It really highlights the need for global collaboration, from local fishermen, who are often the first eyes on the scene, right up to international research teams bringing specialist skills. And we are seeing positive signs. There's evidence of recovery in parts of the Gulf of Mexico, some coral reefs, some wetlands are showing resilience. Communities everywhere are constantly updating their response plans based on what we've learned. Looking ahead, it's just vital we keep monitoring these recovery efforts rigorously, keep talking to the experts, tracking the breakthroughs.
Ultimately, it really boils down to a pretty simple principle, doesn't it? Keeping oil out of the oceans is just fundamental to protect those entire food webs, to make sure these vital, fragile ecosystems thrive for the future.
Couldn't agree more. It's that fundamental.
So as we wrap up this deep dive, we've seen the immediate, often shocking impacts of oil spills, the devastation to wildlife, the damage to habitats. But we've also dug into that long-term harm, the stuff that lingers for years, even decades. Cleaning it up is incredibly tough, full of challenges, but we've also seen real progress, real innovation in detection, in cleanup materials, in using biology itself, leading to, hopefully, better response strategies.
And critically, we've hit on how important speed and coordination are in that response. That idea that lightly oiled environments can recover faster. It makes acting quickly and effectively absolutely vital to minimize that long-term damage.
Yeah. It feels like the global community is constantly learning, maybe the hard way sometimes, but learning nonetheless. Applying those lessons to try and better protect marine life and the people whose livelihoods depend on healthy oceans when the next crisis hits.
Which brings us to a final thought, maybe for you, our listener. Thinking about this complex picture, the environmental impacts, the human responses, the ongoing risks, what's your own connection to the ocean? And are there actions, even small ones, individual or collective, that you feel could contribute to preventing or lessening the impact of future disasters like these? Something to mull over.